is image restoration. So first of all, we seeing the what is the image restoration. The image restoration refer or removal to minimizing the degradation image. A restoration attempt to reconstruct or recover the degradation image into original image. So first we seeing the difference between image enhancement with image restoration. First we seeing the image enhancement. The image enhancement means improve visual appearance or increase the contrast. So what is the increase the contrast? The increase the contrast means the image will be increasing the color. Then the image restoration. The image restoration means the image restoration refer or removal or minimizing the degradation image. So then other than seeing image restoration, the image restoration three types. So first type is a restoration model, second one is a linear filtering, third one is other method. So first restoration model means image formattation model, detector, recorder and noise models. The second type is linear filtering. The linear filtering below is inverse filter and then Wiener filter and FIR filter and least square and regressive, and then other method is blind detection. So next slide. So first image degradation. The degradation means three types of steps. So first step means image acquisition, second one image processing, third one the image storation and transmission. The types of image degradation. Image degradation is three types: one noise and blur and artifacts. So first is noise is unwanted any image, and blur means it makes make it less clear to make the process of image this analysis difficult. Blur means and then artifact. The artifact means there are the extreme intensity or color fluctuation. Then the diagram of image degradation model. So first we seeing the original image and go to the degradation function and the noise will be added and the restoration, the filter will be using and recover the original image. So we seeing the equation. So first the degradation model is g of x comma y equal to f of x comma y convolution h of x comma y plus n of x comma y. The restoration model is given f of x comma y equal to r of x comma y convolution g of x comma. So finally the transfer function is f of u comma v equal to r of u comma v, g of u comma v equal to h minus u of v, and g of uv is equal to g of uv divided by h of uv. So this is a final equation is h of v. So other than so first of all we are seeing the image degradation model. Second one is the degradation model. Degradation model means original image into degradation function and degrade the image. So we seeing the properties. So first property is property of linearity. The first property's naming is property of linearity. The property of linearity is formula is g of x comma y equal to h of x comma f of x comma y. It's set the linear of, so the h of a f1 of x comma y plus b f2 of x comma y equal to a h f1 of x comma y plus b h f2 of x comma y. This is a linearity property. So the linearity property is the external noise n of x comma y assumed to be 0. So first point is the properties of linearity. It means the extreme noise assume that equal to 0. So we are consider the equation. Second one is additive noise. The additive noise means a equal b equal to 1. So first linearity means the extreme noise equal to 0, and then additive properties means a equal to b equal to 1. The equation becomes h of f1 of x comma y plus f2 of x comma y equal to h of f of 1 x comma y plus h of f2 of x comma y. So third one we are seeing the property of homogeneity. The homogeneity means f2 of x comma y equal to 0. So this function is totally deleted. So we are getting to the formula is So we see the property of image degradation. The first property is linearity property. The linearity property means the external noise equal to 0. So the second one is additive property. The additive property means A equal to B equal to 1. So that's the equation below. So third one is homogeneity. The homogeneity is f2 of x comma y equal to 0. So we have considered only h of f1 of x comma y. So h of a f1 of x comma y equal to ah f2 of x comma y is called the property of homogeneity. So the fourth property is property of position or space invariant. Is operating having the input and output relation g of x comma y equal to h of f of x comma y is said to be the position or space invariant. So we are considered to the equation of h of f of x comma x minus a comma y of beta equal to g of x minus a y of beta. So then the equation below. So the equation is properties of equation on additivity, homogeneity, position, space invariant. So the another equations. So next to the topic is noise modeling. The noise and noise, it's an unwanted frequency or unwanted image are affecting the original image. The types of noise is based on distribution, based on correlation, based on nature, based on source. The based on distribution is a Gaussian, Poisson, Gamma distribution. The based on correlation, the white noise, color noise. The based on nature means adaptive and multiplied noise, and based on source means quantization noise and photon noise. So first seeing Gaussian noise. The Gaussian noise means random noise that entire the system can be modeled as the Gaussian or normal distribution. So the formula between the Gaussian noise affect both the dark and light area of the image. So first point is the Gaussian noise affects both light and dark image. So second point is the normal distribution also. The Gaussian also is also called as normal distribution. The first is we seeing the formula is B of z is equal to 1 divided by root of 2 pi sigma e power of minus z minus mu whole square divided by 2 sigma square. So first noise is Gaussian noise. So second one is impulse noise. The impulse noise is also called in salt and pepper noise. Okay, so the impulse noise is also called in short noise and pepper noise and binary noise. It occurs mostly because the sensor or memory problem. So the impulse noise occur only in sensor or memory problem in the system. So given the formula is B of z is equal to P of A for z is equal to A, P of B for the z is equal to B, 0 is otherwise. So third one is a Poisson noise. So Poisson noise is this type of manufactured as a random structure or texture in the image. It's a very common in X-ray image. So most of all, the image occur in X-ray image only. Okay, P of z is equal to x, eta b is equal to z equal to e power minus zb. Then fourth one is exponential noise. These types of noise occur mainly the illumination problem. It's present in the laser imaging. Okay, B of z is equal to a e power of minus az for z greater than or 0 is 0 is otherwise. The fifth one is we seeing the fifth image is gamma noise. The gamma noise is similar to the exponential noise. These types of also occur there mostly due to the illumination problem. The formula is B of z is equal to a power of b into z power of b minus 1 divided by b minus 1 e power of minus a square. Z greater than or is equal to 0. Then relay noise. The relay noise, this type of noise is mostly present in the range of image. The range of mostly used in the remote sensing applications. So the formula is B of z is equal to z divided by b, z minus a e power of z minus a divided by b whole square, z greater than or equal to 0. So the relay noise is considered also mean and variance. The mean formula is a plus root pi by b divided by 4, and variance means b 4 by divided by 5 divided by 4, and seventh one is uniform noise. So we are seeing 7 noise.